So this is the genuine paper run through for paper 3. So let's have a look at this. So I'm trying to draw a frequency polygon. So that means it's joined with straight lines. Okay, I've drawn a straight line. Now I'm going to have to plot something that is halfway between this group. So halfway between 0 and 10 is 5. Halfway between 10 and 20 is 15. Halfway between 20 and 30 is 25. Halfway between 30 and 40 is 35. Halfway between 40 and 50 is 45. So I now want a dot that is, my x value is at 5 and my y value is 12. That would be there. Where my x value is 15, my y value is 25. Where my x value is 25 and my y value is 10. My x value is 35 and my y value is 8. And my x value is 45 and my y value is 5. So if I now join these things together, that gives me a frequency polygon. Okay, and we're done. So midpoint against the frequency. So this one, here's Ben's working, so he's trying to solve this. So first thing he's done is multiply by 3. Now, well done Ben, that is a good thing. We want to get rid of the fraction. But what I need to do is I need to multiply all of those things by 3. So my next step could look like that. 3 brackets p minus 5. And if I've done that, then I suspect most of the people doing this paper will spot it should be 3p and 15. So it should be 3p. So it should be forgotten to multiply 5 by 3. Okay, so that's a really common misconception. Factorise fully. So I know that I've got this. Now I'm going to write that in sort of longhand. I've got 2 times x times x times x times y plus 4 times x times y times y. I'm going to look what's in both of them. So I've got 2 and 4 there. Well, they're both in the 2 times table, so I'm going to put 2 on the outside. They're both in the x times table, so I'm going to take an x off both of them, so they're going to put an x there. They're both in the y times table, so there's going to be a y can get the front as well. And then what have I got left to multiply 2xy by to get this? I've got 2 x's, so that would be x squared. What have I got left over here? I've multiplied by 2, so that's going to give me 2 y's. So because they've got a common factor of 2xy, that's going to go outside my brackets, and then x squared plus 2y is going to go inside my brackets. Question 3. Mia buys this 25 bags for 200 oranges, puts the oranges into bags, she sells 5. Right, so okay. So first off, I'm going to work out, I've got £25 for 200 oranges. So so let's go £25 divided by 200 oranges. That gives me 12.5p per orange. Okay, so 12.5p per orange. Mia's held bags of oranges for £1 each, so I've got 5 oranges in each bag, so that's 5 times 12.5p. So that's going to cost me £62.50 to buy said bags. That's going to cost me let's say that again. It's going to cost me 62.5 pence to fill a bag with oranges, and I'm going to sell those same oranges for £1. So I'm going to sell those same oranges for £1. So that means that my profit is £1 subtract 62.5 60.5 pence. I'm messing myself around there. So it's £1 divided by subtract 62.5 pence. So that means I'm going to need to work out the profit, which is 37.5 pence. So if I'm trying to work out my percentage profit, I know that I'm going to I've made an extra 37. So I'm making, £1 out of every 62.5 pence. So if we just make them in the same unit, I could have 100 pence over 62.5 pence. So type that into my calculator. So that gives me 1.6, so which is 160%. So I had 100% and I've added on 60% to get 160%. So my percentage profit would be 60%. Now, I'm just sat here thinking that there's a way, easier way to explain that, but I'm not going to explain it a different way. Stick with the way we've done. Right. Question 4. Oh, there's loads of ways to do this. There's loads of ways to do this. It was really interesting. Loads of people gave us the same sort of answer, and there's on the mark scheme there's lots of different types of way of doing it. I'm just going to say, right, I'm going to change everything. I'm going to, in London, 2 kilograms of carrots cost me £3.75. So I'm just going to change my New York value into that. So New York, I've got £5. £5. So I'm going to work out what £5 is in kilograms. So to go from pounds to kilograms, I'm going to divide by 2.2. So in New York, £5 is approximately 2.27 kilograms. Okay, so if I bought them that £5 is 2.2 kilograms. Now in America, New York, that has cost me, so 2.27, so still in New York, 2.27 kilograms, which is £5, costs $4.90. Now I'm going to change $4.90, so to go from dollars to pounds, I'm going to divide by 1.2. So $4.90 divided by 1.2. So that's going to tell me that 2.27 kilograms costs £4 and 8 pence ish. Okay, £4 and 2.27 kilograms cost me that. So if I wanted to work out the cost of 1 kilogram in New York, I'm just going to divide that by 2.27, and so my cost would also divide by 2.27. So divide that by 2.27. So I now know that in New York, 1 kilogram cost me £1.79, £1.80-ish. Let's just put all the digits in so I don't have to change my answer. So that's going to cost me about this much. So now I want to work out the cost of 2 kilograms in New York. So I'm going to multiply that by 2. So if I bought it in New York, it would cost me that much, which is about, so is it £3.60. So if I bought it in the UK, in London, it would cost me £3.75. If it bought it in New York, it would cost me 2 kilograms would cost me £3.60. So New York is cheaper. Other ways are available. You just need to get the same amount of the stuff in the same currency. But that's how I do that question. Right, error interval. So this is a really nice one. So my answer comes up as 23.8. It's been, some numbers round up to that, some round down to it. So the smallest number that rounds up to it is 23.75. The largest one that rounds down to it is 23.7, 8, 4, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, and I could just sit here for the rest of the hour putting 9. So that's a bit impractical. So what I would say is it gets really, really close to 23.85, but it doesn't get there. So that's why I put 23.85. It can't equal but 23.75. It can. Question 6. If I'm looking at question 6. So a plane takes 2 hours and 24 minutes to try from London to Albuquerque. Work out the average speed. Well, 2 hours is really easy. We know that's 2 hours. That's 2 hours. 24 minutes is 24 out of 60 minutes. 24 out of 60 minutes. So if I'm trying to work that out, I could just type into my calculator 24 over 60. So actually that's 0.4. So I've got 2 hours and 0.4 hours. So my time would be 2.4 hours. So that's how I make it into a decimal time. And I know that speed equals distance divided by time. So my distance is 1,512. And my time now is not 2 hours 24 minutes, it's 2.4 hours. So I could do 1,512 divided by 2.4. And that gives me 630 kilometers per hour. Now, some people, if you wanted to, you could change that so it's 1,512 to show how it works. 1,512 divided by 144, that's how many minutes that is. And then I multiply that by 60 to turn it into hours, and it gives me the same answer. So different ways to do it, but it's up to you. Now, I think I'm a fan of a visual, so I like trying to understand what's going on here. So from A to B, so this triangle here, I'm going from 2 to 8. So I've gone 6 units across, and I've gone from 7 to 12, so I've gone 5 units up. So 6 units across and 5 units up. Now that is, so BC, so that bit there, so this line here is half as big as this line here. So I'm just going to do a smaller version of that triangle. So half of 6 would be 3, and half of 5 would be 2.5. So if I'm from here, I'm going to go 3 units to the right, I'm going to go 2.5 units up. So 3 units to the right of 8 would give me 11, and 2.5 units up from 12 gets me to 14.5. So that's going to 8 and 14.5. We're winning. Question 8. I'm going to go back to my other calculator because I feel like more and more people are going to use this type. So I'm just going to, sorry, white calculator, you're out. The trapezium has an area of 112. Find the perimeter. So some people do this in a really nice way. They've said, right, well, if this was just a rectangle, 8 times 12 is 96. So 8 times 12 is 9. So I've got to do 112, subtract 96. I'm trying to think of one of the people in my class who didn't do this bit right. No name is mentioned. 112 subtract 96. So that's 16 centimetres squared. Right, so now I know that that's 16 centimetres squared. I always get a bit confused with triangles. So I always think, well, if it wasn't a triangle, it was a rectangle, what would I do? So if this bit here is 16, then this whole thing must be 32. That whole thing's got to be 32. And I know that it's 8 tall. So if that's 8 tall, how wide is this thing going to have to be? 8 times something gets me to 32. So 8 times 4 is going to get me to 32. So 8 times 4 is 32. So this bit here is going to be 16. So I know that this length here must be 4. So now I've got my triangle again. So I always think having these pictures just helps me understand what's going on. So now I've got a right angled triangle. I know that Pythagoras taught me that 4 squared plus 8 squared gives me x squared. So I can type that into my calculator. 4 squared plus 8 squared gives me 80. So I know that this bit here is worth 80. So x would be the square root of 80. I'm just going to press that into a decimal, which is about 8.94 centimetres. So I know that on my diagram that this bit here is about 8.94 centimetres. So if I wanted to work out the perimeter of my shape, start up here. What's he called? Stickman Bob, courtesy of Mr. Corrin. So he's going to walk 12 centimetres along there, 4 centimetres along there, and he's going to walk his 8.94 centimetres along here, add 12 centimetres along there, and then 8 centimetres up there. So 12 plus 4 plus 8.94 plus 12 plus 8, and that gives me an answer of approximately 44.94. It says give my answer to 3 significant figures. So there's my 3 most significant figures. Does 4 cause me to round up or stay the same? Stay the same, so I'm going to add 0. So my answer there would be 44.9 centimetres. 44.9 centimetres on my answer line. Question 9. So write this as an ordinary number. So I've got to just times that by 10 6 times. So it's going to become 50. So that's times it by once. twice, 3 times, 4 times, 5 times, 6 times. Okay, so that's how it works. This thing in standard form, so it's got to be, first bit's got to be between 1 and 10, so it's going to be 3.5, and I need to shift all my digits one place, 2 places across to the right, so my answer there will be 3.5 times 10 to the negative 2. Right, use your calculator to work out this. Right, so the more fluent you are with your calculator, the easier you'll find a question like this. So makes sense for you to practice it. So I'm going to press my fraction button first. 1.8, press the little square with a box on, so cubed, press to the right so I can get rid of that bit, times by cos 35. Now hopefully your teacher has made you check cos 35. Oh, so then I'm going to close my bracket on the top. Sorry, so if I'm not there, so I want to get up onto the top, scroll to the end, close my bracket on the top, and squared, so that whole thing's squared. Over on the bottom, the cubed root, so shift and this one, so that's my cube root. Go back in to make that 3. Cube root of 17.4 minus tan 85. And I'm going to have to close my bracket, otherwise it was a syntax error. So if I type that in, I get an answer of 12.580777014. So it says give your answer to 3 significant figures. There we go, so I'm just going to look at those ones. 8 does cause me to round up, so I'm going to get an answer of approximately 12.6. Find the value of n here. Right, I know that 3 to the n plus 20, so multiply them together, divided by 3 to the 8 gives me 3 to the 14. So I know that this bit here, subtract this bit here, gives me that. So I know that n plus 20 minus 8 gives me 14. So then I'm going to say that n plus 20 must be worth 22, and that n must be 2. Right, so this one, I'm just going to break it up. So I've got 64 to the power of 2/3, and I've got, and I've got m to the 12 to the power of 2/3. So that's what I'm just trying to recognise, that because I'm doing that to the 2/3, so I can break those two up into 2 individual pieces. So I'm going to do the cube root of 64 and then square it, and I'm going to do the cube root of m to the 12 and then square it. Now the cube root of 64 is 4. I can type that into my calculator, but trust me. So I'm going to have 4 squared, and here the cubed root of m to the 12. Well, the cube root means m to the 12 to the power of 1/3, so that just gives me m to the power of 4. That's m to the power of 4, and that's going to be squared as well. So 4 squared would be 16. M to the 4 squared is going to be 4 times 2, be 16 m to the power 8. 16 m to the power 8. Right, this one, after a holiday, 10%. Right, so I know that is Jim correct? No, Jim is not correct. Right, why is that? Because my original amount, so I had an amount, 100%, and I added on 10%, and that value became £440. So I know that 110% must be £440, so 10% must be £40, so I've just divided by 11 there, and so times that by 10, so my original amount must have been 400. Yeah, lots of people prove that by saying 10% of 396, 396 is 39.6. If I add it on, it does not get me to 440, which is also a totally valid answer. So what we're going to say is 100% is £400. Right. In November, Tina sold 25% fewer bikes than October. In December, Tina sold 50% more bikes than November. In December, right, so hold on. So December is November's amount plus 50%. plus 50%. So that is 150%. So in November, December is 150%. So Tina sold 180 bikes. So 150% of November's amount. So I'm just going to divide that by 1.5. If I divide both sides by 1.5, then I'm just going to have November's amount. So 150 is 1.5. I'm going to have 180 divided by 1.5. So now I know that in November, Tina sold 120 bikes. There you go. Half of that would be 60. Add it on 180. Perfect. In Tina, in November, she sold 25% fewer bikes in October. So 120 was the number she sold in November. Is October times by, now it's 25% fewer, so that means she had 100%, and we've taken away 25%, so that's 75%. So how do I get rid of times by 75%? Well, I'm just going to divide both sides by 75%, which is 0.75. So I'm going to do 120 divided by 0.75, and that gives me 160 bikes for October. Does that work? A quarter of October's bikes is 40. Take it away and I get November's, which is 120. So actually, yeah, that sort of steps through. So 160 bikes. Right, this one. Right, describe the graph. So x cubed. So things I want you to know. So I want you to know x squared. Looks a bit like that. So happy face. Negative x squared. Looks a bit like that, so it might be up, down, left, right a bit, but negative x squared, that's the most, one of the things we want you to recognise. So if I'm looking here, I've got 5 minus x squared, so which one's got that look of a grumpy face on it? Right, hold on, so B, so I know that this point here must be 5, so that's definitely B, right, okay. Cubics, so cubics, you get big negatives coming up to 0, and then big positives going away from 0, so it goes up like that. So that would be y equals x cubed. So y equals negative x cubed. It's going to be the same sort of thing, but going downhill, like that. So where is my cubic? So that's going to have to be E. So that's the only one that starts with, goes up and across. So we've done that. This one is an exponential graph. Okay, so I've got 3 to the power of x. So that means y equals a to the power of x. So I know that at this point here, it's going to go through at a, and then every time it's just going to multiply by a, multiply by a, multiply by a, so it gets really steep. And this is like exponential growth going this way and decay going this way. So which one of my things looks like that? That has to be h. And then this one, a reciprocal graph. So as x gets bigger, my answer gets smaller. So if I got 2, 1, and then it goes 1 over 2 over 2, 2 over 3, 2 over 4, 2 over 5, 2 over 6, 2 over 6. So it goes ever closer towards the x-axis. When it's got 2 over a half, 2 over a third, 2 over a quarter, 2 over, that gets bigger and bigger and bigger. And then likewise in this quadrant, it's going to be going down and away. So that one is going to be C. Okay, this one here would be something along the lines of negative 2 over x or something like that. So this is y equals a to the power of x. This one will be an x squared minus something. Yeah, this one will be a exponential decay one, so that might be a to the negative x, something like that. What else have I got? This will be y equals 1 over x or something like that, and this will be some sort of variant of x cubed. Right, this one, area of triangle, so area of any triangle. Now some of my class were doing half base times height. Now that's sort of right in some ways. If I've got this thing here, where this is 3 and this is 4, I would do a half times 3 times 4 times the sine of the angle between them. So times the sine 90. Now sine 90 is 1, so actually we don't need to bother doing that, and when we're learning maths we don't put these extra complicated steps in, so that one will just give me 6. Now when I've got a non-right angle triangle like this, I maybe want to use a formula that's on my formula sheet. So area of triangle is a half AB sine C. Now, the important thing is a half times the length times the angle between them. Half times the length times the angle between them. So in this example, I would literally type in, I would go area is half times 8.3 times 9.8 times sine 35. And that's it. So if I just wrote that down, and the formula sheet is in my is on my paper, then I can get marks for that. Also 8.3 times 9.8 times sine 35. Close my bracket. So that gives me 23.3-ish. 23.3. So now, and the thing is that I should really write all this down because Mr. Cohen will tell me off if I don't. So there we go. And it says the three significant figures, so they're add 0. Boom. Right, thanks Mr. Cohen. Next, question 15. We've got this one. Right, I've got red and blue pens in a box. Roger takes one, he notes the colour and puts it back. Right, he does this 2 more times. Okay. Show the probability Roger takes at least 2 blue pens. Right, so my options are he takes a blue pen, he takes a blue pen, and he takes a blue pen. There you go, that's 3 blue pens. Easy, well done. Right, other alternatives, he could take a blue pen, then a blue pen, then a red pen. So he's got 2 blues there. Or he could take a blue pen, and a red pen, and a blue pen. Or last, he could take a red first and follow it by 2 blues. Okay, so they're actually the things I'm interested in. Now, if I were to say, right, so the chance of getting a blue pen was 7 blue pens out of 10. Now, let's have a look. He puts it back in the box, so my probabilities don't change here. So there was 7 in before, I've put them back in, so there's still 7. So that would be 7 over 10 times 7 over 10 times 7 over 10. So that's going to give me a total of 343 over 1,000. I can type it in, but trust me, that gives me that. So the next one. So the chance of getting a blue this time would be still 7 out of 10. The chance of getting a blue again is still 7 out of 10, but this time the chance of getting a red is 3 out of 10. So now I'm going to do 7 out of 10 times 7 out of 10 times... The thing is, I'm humouring myself. So it's going to give me 147 out of 1,000. Right, this one, how is it going to be any different? Well, this time it will be 7 out of 10 times by 3 out of 10 times by 7 out of 10. So that's going to give me 147 out of 1,000. And this one's going to give me 3 out of 10, sorry, 7 out of 10 times 7 out of 10. And that's also going to give me 147 out of 1,000. Now this is where I'm going to mess up if I do any adding. So I've got that chance plus that chance plus that chance plus that chance. So I'm just going to add all those probabilities together. Over 1,000. So 3, 4, 3 plus 3 times 147. Oh, plus, sorry. So that's going to give me an answer of 784 out of 1,000. 784 out of 1,000. So if I just type that into my calculator, 784 divided by 1,000, and it simplifies to that fraction. So if I'm trying to prove it, I suppose I could say, right, how many 98s get me to 784? And that gives me 8. So I know I'm dividing by 8. So 784 over that. If I was trying to be super thorough, divide by 8, divide by 8. That gives me 98 over 125. Okay. Question 16. We've got this one. We've got a volume of cone. The vertical height of the cone is 3 times the height of the cylinder. Right, okay, this is interesting. So I know that's 8. So this, we'll call this one here A. Doesn't matter what we call it, just pick a letter. So I know that this bit here must be 3A. Here must be 3A. So let's work out. So if I've just got my cone to start with. So my cone, the volume of a cone is 1/3 times pi times 8 squared times 3A times my height. My cylinder at the bottom is going to be pi times the radius squared times by the height. So let's do some cancel out. A third times 3, so they're going to cancel off. So that just leaves me with 64a times pi. 64a times pi. This bit here is just going to give me 64a times pi. So if I add them together, 64a times pi, that's going to give me the volume of the solid shape, 640 pi. So I now know that 128a times pi gives me 640 pi. So if I divide both sides by 128 pi, so now I know that we don't know what a is worth, but they're going to cancel off anyway, so it doesn't actually matter. No, we're going to 100, so 640 divided by 128, and that's just going to leave me with a equals 5. So the pi's cancel off, and then that cancels off. So I'm just left with these cancel off, these cancel off. So I'm just left with a equals 5. Just make sure I finish the question. Work out the vertical height of the cone. Well, I know that the cylinder's height a, so the cone has got to have a height of 15. Right, fantastic. Cooking on gas, as they say. Right, solve this equation. So I've got to try and make the denominators the same. I'm going to try and, if I'm trying to do this, I'm going to make the denominators the same. So I'm going to multiply those things together. So I'm going to multiply the first one by 3x plus 1. And I'm going to multiply the second one by 3x minus 1. And because I've multiplied them both by that, I'm going to multiply this side by 3x plus 1 times 3x minus 1. So, right, so I've got 5x lots of 3x plus 1. And I've got 2x lots of 3x minus 1. So let's, so that just gives me 1. Oh, so that would be 1 at the moment. Sorry, that would be 1 at the moment, but it won't be in a minute. So that's going to give me 15x squared plus 5x minus, I'm just going to leave this in brackets because I always make a little mistake on this, 6x squared minus 2x, all over 9x squared minus 1. So if I just expand out that bottom bit, that's what I get, 9x squared minus 1. So then if I multiply that up, so I'm going to move that up to this side, so I'm going to times both sides by 9x minus 1. That gives me 15x squared plus 5x minus 6x squared. This is why I put the brackets in, because it reminds me about this step. Subtract negative 2x, that's plus 2x. And that's going to give me 9x squared minus 1. So now what happens here? What have I got left? So I've got 9x squared plus 7x here. 15x minus 6x is 9x squared. 5x plus 2x gives me 7x. That gives me 9x squared minus 1. So then I can subtract 9x squared from both sides. That gives me 7x equals negative 1. And then I'm going to divide both sides by 7. And I get x equals negative 1/7. And we are done. Next question. Do a quick change for a sharper pencil. Right, so I'm just going to tick these off as we go. Right, so 100 people. So I've got to put these numbers in. 32 people like all 3 drinks. So 32, you go in the middle. There you go. Now the mark scheme here says 4 marks for everything, 3 marks for 6, 7 or 8 regions correct, 2 marks for 4 or 5 correct, 1 mark for 2 or 3. So far I haven't got a mark. 15 people like coffee and hot chocolate but not tea. So coffee and hot chocolate but not tea. So 15 must go in there. So now I've got a mark for putting that one in. So I've used that information. 43 people like coffee and tea. So coffee and tea. So that whole section there is worth 43. So already got 32 of them, so that's going to have to be 43 subtract 32, so that gives me 11. So I've used that one. 39 people like hot chocolate, tea and hot chocolate, so that's this bit here. So that is worth 39, so the missing bit there has got to be 7. So I've used that bit of information. 67 people like coffee, so 11 plus 32 plus 15. This is where I make some sort of stupid mistake and I feel like a fool. So that gives me 58 people liking coffee, but I know that 67 do. So 67 minus 58 is 9, hopefully. That's 9 people like coffee. 58 people like hot chocolate. So hot chocolate, 15, 32, 7. Now obviously you're allowed to use your calculator, but I'm trying to do a video fairly sharpish. So that gives me 54 people, so the missing thing must be 4 there. 5 people like only tea, so 5 people like only tea, so 5 goes in there. Then I'm going to add all of these things together. So 20, 25, 32, 64, 79, 83. So that gives me 83, and I'll double check my sums and see if I've made anything stupid. So 100 subtract 83, and that would leave me with 17 on the outside somewhere. Now, it says one of the people who's chosen at random, given that this person likes coffee. Well, I know how many people like coffee. 67 people like coffee. So if I've got a fraction where the denominator is 67, that is a mark. What is the probability they also like hot chocolate? So I'm looking at this circle, they like coffee, they also like hot chocolate. So that is the sum of these two sections for them. So for me it's 47, because hopefully I've done it correctly. So it'd be 47 out of 67. If you've got different values, if you've got just 67 on the bottom because it's given to you in the question, that's a mark. Or if you've got your value there added together as the numerator, that's a mark. Right, this one. The height of each paper is, the thickness of each paper is that. Calculate the upper bound for the number of sheets. Right, so if I want lots of sheets, so if I want a big answer, I want my pile to be big and I want each sheet to be thin. Okay, that's my brain thinking this. Now every time you see anything, when you've got anything about bounds, just write out the upper and lower bounds for things. So it's the same as our error interval question earlier on. As soon as I can see 10.45 or 10.35 or 0.17 gives me 0.175 and 0.165. Now just be aware that the units are different. So because this is millimetres, then we're trying to get to the nearest millimetre. So because we're trying to get my answer as the same thing, I want both of my units to be the same. So that's how many centimetres it would be. So I'm just going to change that to 104.5 millimetres, and this one to 103.5 millimetres. So same thing, but because I'm trying to get the units to be the same. So if I want a massive pile, so I want my pile to be 104.5, and I want each sheet to be as thin as possible, 0.165. And I can just type that into my calculator. Oh, this is undo. Clear. So 104.5 divided by 0.165, and that gives me an answer of 633.3333. Okay, you're welcome, Mr. Corin. Look at me being a good example. Right, so I've got all those decimal points, so 633. Right, every time you've got an angles question, you just write down an angle and you write down the fact. So this one here, circle theorem, angle at the centre, twice angle at circumference. Twice angle at circumference. So I know whatever one in the outside is, the middle one's going to be twice as big. Over here, I know that this is going to be 100 because opposite angles, I'm just going to write where it is, opposite angles of cyclic quadrilateral add to 180 degrees. Okay, so now I know that OBC is this one, so I'm going to do 43, add 160, add 100. That gives me 303. So I'm going to do 360 minus 303 gives me 57 angles in a quadrilateral. Add to 360 degrees. Boom. Next. Right, simultaneous equations with a quadratic. So first off, I'm going to rearrange this bottom one so it just says y equals. So y equals 2 minus 3x. So now I'm going to write this top equation again. I've got 3x squared plus 2 lots of y squared equals 44. Now this is 3x squared, and I've got 2 lots, but instead of writing y, I'm going to write 2 minus 3x all squared equals 44. I'm going to draw myself out a little grid. 2 minus 3x, 2 minus 3x, 4 minus 6x minus 6x plus 9x squared. So 3x squared plus 2 lots of 9x squared minus 12x plus 4 equals 44. So then that's going to give me 3x squared plus 18x squared minus 24x plus 8 equals 44. So we can then tidy this thing up. That gives me 21x squared minus 24x's plus 8 equals 44. Then I'm going to subtract 44 from both sides. Zero. They're all, so I've got that thing, 21x squared minus 24x's minus, 36, equals 0. So they're all in the 3 times table, so I'm just going to divide them all by 3. Now, you don't have to do that, it just makes it, I'm trying to work with as smaller numbers as possible. Obviously, it doesn't matter if I do 0 divided by 3, it's still going to be 0. So then I'm going to factorise this thing, or use the quadratic formula, or whatever you want to do. I'm going to factorise it. I've got 7x squared up here, and I've got minus 12 here. I'm looking for things that multiply together to get negative 84. And they also add together to get negative 8. So it could be 1 and 84, could be 2 and 42, could be 3 and 14, could be 4 and 21, it could be 6 and 7, oh no, 6 and, no, it's not 3 and 14, it's 3 and 28, 6 and 14, 7 and 12, so if I'm trying to do that, what am I doing? Can't find the pause button for me to find what mistake I've made. Oh, I haven't made a mistake, I've just it's going to be multiplied together, I think, negative 14, negative 8, so it's going to need to be positive 6 and negative 14. So plus 6x minus 14x. So they're both in this 7x times table. 7x times x gives me 7x squared. 7x times 6 gives me 6x. X times 6 gives me 6x. 7x times negative 2 gives me negative 14x. So my two brackets could be 7x plus 6 and x minus 2 equals 0. So now my x values have got to be, so 7x has got to equal negative 6, so x has got to equal negative 6/7, and x has got to equal 2, so x equals 2. And then I'm just going to put those values back in up here to get my answer. Okay, so if x equals 2, then y equals 2 minus 3 lots of 2, that gives me negative 4. So that coordinate would be 2, negative 4. And if x equals negative 6/7, then I'm going to go 2 lots of 3 lots of negative 6/7. So that is going to be 2 plus 18/7. So that's going to give me 32/7. 2 is 14/7 plus 18/7 is 32/7. So my coordinates then are 2, -4 and -6/7, 32/7. Right. Okay, question 23. Am I going to make it 7 minutes before lunch? Right. Circle this, a straight line, find that the coordinates of P is a tangent at the point P. So, draw a diagram. There's my diagram. Straight line with equation that is a tangent to C at the point P. So, if I rearrange this equation, I get 3x equals 2y plus 52. And then I end up with 2y equals 3x minus 52, y equals 3 over 2x minus 26, 3 over 2x minus 26. So that would give me my first mark. So I know that, okay, so if I've got a line like that, then my gradient of my straight line with line is a tangent. So that line there has got a gradient of 3 over 2. So that means for every 3 across I go 2 up. So if I'm looking for a perpendicular line, that tangent is going to need to be its negative reciprocal. So it's going to need to be negative 2/3. Okay, negative 2/3. So I now know that that is going to be negative 2/3. So it's going to be like here somewhere-ish, I think. So this is my 2 over 3, and this is going to be my 3 and minus 2. So I now know that this line here, the equation of that line is going to be y equals negative 2/3 of x plus 0, because it's going to go through my origin. And I know that this one is 3 over 2x minus 26 equals y. So I know that y equals that, and I also know that y equals this. And that y is the same as that y where they meet. So I've actually got this equation, 3 over 2x minus 26 is the same as negative 2/3 of x. So I've just got to solve this and I can work out what my x value is. So I'm going to multiply everything by 6, multiply everything by 6, yeah, I'll do that. Oh no, I'll just make, what should I do? Yeah, let's multiply everything by 6, go for it. So that's going to give me 18 over 2x minus, now if you're thinking why am I multiplying by 6, I just don't like these fractions, so I'm just going to make them easier to get rid of those fractions. And negative 2/3 times 6 is going to give me negative 12/3 of x. So then that gives me 9x minus 156 equals negative 4x. So then I'm going to solve that equation, so I'm going to add 4x to both sides, and I'm going to add 156 to both sides. So that gives me 13x equals 156. So divide both sides by 13, and I get x equals 12. So now if x equals 12, I'm just going to substitute that into either of my other equations. So y would equal negative 2/3 of x plus 0. So y would equal negative 8. Now if I was thorough, I could substitute that into the other one as well. But time is of the essence. Right. This is a quick one to go through. Right. So I've got to try and work out that this is a straight line. So this is a straight line. So first off, I'm going to work out how to go from C to B. C to B. So C to B. So I'm going to go from here. I'm going to go backwards along this line. So that is negative 2B. I'm going to go backwards along that line, negative A. I'm going to go forwards along this one. So c to b is the same as negative 2b minus a plus 3b. So that's just going to be b minus a. Now I know that this bit here of my line is b to n to c. So that's 3 shares and this is 5 shares. So that is 3/8. So to go from c to n, it's 3/8 of c to b. So that's 3/8 of b minus a. Right. Now if I wanted to go from m to p, I'm going to go some distance. I'm going to call that a lambda. It doesn't matter what symbol you put there. It's going to be some distance along there. Okay, so it's going to be some distance along there. Or my other way of going from m to p is to go from m to a, and then I'm going to go from a to c, and then I'm going to go from c to p. Now they're both the same thing, but m to a is a half of a, because that's the midpoint. A to c is 2b, and then c to p is k times 2b. Okay, because it's some distance. That's what we're trying to work out, that value of k. So then I've got a half of a plus half of k plus what do I want? 1 plus k lots of 2b. 1 plus k lots of 2b. Okay, so I've missed a step here, sorry. So that's c to n. So if I wanted to go from m to n, I'm going to go half of a, or sorry, m to n, I'm going to go half of a plus 2b, and then I'm going to go from plus c to n. So that's the thing I should have put in here, plus c to n. So that gives me a half of a plus 2b plus 3/8 of b minus 3/8 of a. So now if I get into my components here, 1/2 of a minus 3/8 of a is going to give me 1/8 of a. 2b plus 3/8 of b is going to give me plus 19/8 of b. So actually that is what I should have here. M to p is lambda times m to n, not c to n, so that's the wrong thing there. So it's going to be lambda times by 1/8 of a plus 19/8 of b. Sorry, just been disturbed. Right, so we've got that. So I've now got some amount of that gives me that. Some amount of that gives me this. So there's two different expressions. So I've got lambda times 1/8 of a plus 19 over 8 lots of b, plus 1/2 of a plus 1 plus k lots of 2b. Okay, so that's my one lot and that's my k lots. So now I know that my a component's got to be the same. So I know that lambda has got to equal 4, because 4 times 1/8 gives me a half. So I know that in order for this bit to be worth half an a, that lambda must be worth 4. So now I know that this thing should say 4 lots of 1/8 of a plus 76 over 8. So that's just 19 times 4. 76 over 8 lots of b. Oh, sorry, so just put that's 4 there. Equals 1/2 a plus 1 plus k lots of 2b. So then I can know that my 1 plus k lots of 2b is the same as 76 over 8 lots of b. So if I divide both sides by 2b, so if I divide both sides by 2b, then that's going to become 76 over 16 equals 1 plus k. So K, oh dear, sorry, I've run out of space. K is equal to 76 over 16 minus 1. I can just type that into my calculator, hopefully. 76 over 16 minus 1. And that gives me an answer of 15 over 4, which hopefully is what I'm looking for. So K is 15 over 4. Now I know it's a bit of a mess, sorry. Interruption didn't help, and me not writing down the right thing there does not help. Right. Done. Oh, done and done. Splendid. Right, to duty. Thank you very much.